This is Fardina Fathmiul. Today I'm going to present our paper named Towards More Equitable Question Answering System. How much more data do you need? Along with my co-authors, Arnab, Debnath, and Navid Rajabi. This paper has been supervised by Professor Antonius from George Mason University. In a question answering system, we provide two types of inputs. One is a contest and a question. Here in this system, the task is to generate the answer span of test as an output. Like here, the green background highlights the answer span for the given contest and the question. Now, for this task, we train a model by providing answer span as a ground truth. And during testing, we expect that for a given question and the contest, the model will be able to predict the minimal span of the selected answer over the paragraph. As an example, we can see a monolingual setting on the left, and on the right, we can see an multilingual setting. And we expect that the trained model in this multilingual setting on the right would be able to generate answers in many languages. As a dataset for training purpose, we have focused on monolingual dataset squad based on English language. And for evaluation, we have used a multilingual dataset named TidyQA. Some common challenges of these datasets are they are very expensive and they need huge labeling effort. For example, Squad has like 87 QA pairs, and on the other hand, TidyQA has lots of instances covering 11 typologically diverse languages, which is making this hard to do labeling, and it's very also expensive. So based on them, our paper focuses on some key research questions. Like, can we take the advantage of the existing monolingual dataset in order to produce QA system in many languages? How data augmentation techniques such as machine translation may help in few shot approaches? And more importantly, how much more data do we need? Motivated by that, we aim to build a good QA system in all languages. So the next segment of the presentation will be delivered by Arnab Debnath. Thank you.
Thank you, Fardina. So this is an overview of our framework. And we have done several experiments here. For the baseline, we have tried to reproduce two experiments. One is the zero shot, which performs worst, and another one, what we call is skyline, performs best. And for the zero shot experiment, we trained our MBERT model on all of the English squad dataset and evaluate on TidyQA dataset, which is multilingual. And this is a real zero shot experiment, as in the training stage, the model has not seen any training instances from the TidyQA. And for the skyline, we train and evaluate on all of the languages from TidyQA dataset. So our target was to bridge the gap between these two using data augmentation and few shot. So now, after the zero shot setting, we have done a bunch of multilingual few shot setting where we added some instances like 10, 50, 100, or 500 languages, 500 instances from the TidyQA dataset for each language. And we have done also some two kinds of data augmentation. One, we have used Google Translation, where we augment the squad dataset with Google translated squad data for each language, which we call T-squad. And in another data augmentation technique, for each QA pair, we randomly pick a language for context and answer, but change the language of the question. And we call this dataset as M-squad. And finally, we also do few shot on top of these augmented datasets. Now, if we look at our quantitative results, our baseline has an F1 score of 58 and Skyline has 80.8. And using T-squad or M-squad for data augmentation, we get a better F1 score than the baseline. And for multilingual few shot, where we add only a small portion such as 500 instances per language from TidyQA, we can see a big jump in the F1 score. And moreover, when we add the augmented datasets like M-squad and T-squad on top of this multilingual few shot, we can achieve as close as 98% of the Skyline with only using a few instances from the TidyQA. The next part will be presented by Navid.
Thank you, Arnab. So the last part of our experiment was to investigate the best way to do budget allocation into different languages. So in here, actually, we wanted to see what's the best way to allocate 4,500 of new instances from TidyQA Transit to get the better result and the most equitable one that I'm going to explain now. So in the no budget scenario, we don't have any extra actually instance from tidy QA. This is going to be actually considered as zero shot, and we achieve 58% of accuracy. In the monolingual scenario, we have added a maximum of 4,500 instances to one language at a time and tested on all the languages. And we achieved 72.3% of accuracy. In trilingual actually scenario, we have selected 3 languages randomly, and we have assigned 1,500 instances to each of them. So we achieved 74.5%. And in the uniform scenario, we have allocated 500 instances to each language, and we got the highest performance and the most equitable one. And the ideal scenario is to have a maximum of 4,500 instances allocated to each language. So it's going to be very less data efficient, which is going to actually lead to 79.9%. In terms of contribution, we have investigated to actually utilize already existing and low cost techniques like neural machine translation, and also adding a very small portion of the new data set to increase the performance. And also we have investigated different budget allocation scenarios to find the optimum point. In terms of the takeaway, we have realized that data augmentation through translation, along with few shot fine-tuning and uniform budget allocation, can actually lead us to 98% of the top accuracy, which actually is using 10x more data. Thank you so much for your patience.